Good morning. Welcome to Rogani College of Engineering and Technology. I am Reggie, Associate Professor, Department of ECE. Today we are going to see about microwave filter design. Microwave filter design. On completion, students will be able to understand what is a microwave filter, draw the microwave filter characteristic of. Microwave filter design. A filter is a two-port network used to control the frequency response at a certain point in the RF or microwave system by providing transmission at frequency with the passband of the filter and attenuation in the stop band. Typical frequency response include low pass, high pass, band pass and band reject characteristics. Application can be found in virtually and any one of RF or microwave communication, radar or test and measurement. Filter designed using the image parameter method consists of cascaded two-port filter to provide desired cutoff frequency and the attenuation characteristics but not allow the specification of a particular frequency response over the complete operating range. Thus, although the procedure is relatively simple, the design of filter by image parametric method often used to iterated many times to achieve the desired result. A more modern procedure called the insertion loss method uses network synthesis technique to design filter with a completely specified frequency response. The design is simplified by the beginning with a low pass filter prototype that are normalized in terms of impedance and frequency. Transformation are then applied to convert prototype design to a desired frequency range and impedance level. Both the image parameter insertion loss filter design leads to circuit using lumped element. For microwave applications, such design are usually modified to employ distributed element consisting of transmission line session. The richer transformation and Kuroda identities provide this step. Image parameter of T and pi network. So as we know already, the ABCD parameter for a T network and pi network. Using the Z parameter, we can determine Z11 is equal to Z22 plus Z2 plus Z1 by 2. Image impedance ZIT is equal to square root of Z1 Z2 into square root of 1 plus Z1 by 4 Z2. Propagation constant e power gamma equal 1 by Z1 by 2 Z2 plus root of Z1 by Z2 plus Z1 square by 4 Z square. Similarly, for pi filter, A is equal to 1 plus Z2 by 2 Z2, B is equal to Z1, C is equal to 1 by Z2 plus Z1 by 4 Z square, D is equal to 1 plus Z1 by 2 Z2, Y11 is equal to Y22 is equal to 1 by Z1 plus 1 by 2 Z2. Image impedance, which is equal to square root of Z1 Z2 square root of 1 plus Z1 by 4 Z2. Propagation constant e power gamma equal to 1 plus Z1 by 2 Z2 plus square root of Z1 by Z2 Z1 square plus 4 Z2. Filter designed by image parameter method. Constant K filter series. First, consider a T network shown in figure. Let us see the low pass filter using the series inductor shunt capacitor tend to block high frequency signal while passing the low frequency. So it is given in this diagram. So the value of constant K filter ZIT is equal to square root of Z1 Z2 square root of 1 plus Z1 by 4 Z2 is equal to root of j omega L by j omega C, which is square root of 1 plus j omega L by 4 into 1 by j omega C. So ZIT equal to R0 square root of 1 minus omega 2 minus omega C the square. The propagation constant can be determined e power gamma is equal to 1 minus 2 omega square by omega C plus 2 omega by omega C square root of omega by omega C whole square minus 1. Constant K filter. Typically, pass band and stop band characteristics are low pass, constant K session. Pass band, stop band. So omega is less than omega C. This is called pass band of the filter. ZIT is real, gamma is imaginary. For omega is greater than omega C, this is stop band filter. ZIT is imaginary, gamma is real. So typical phase and attenuation constant are sketched in previous system. So this type of filter is called constant K low pass filter. There are only two parameters to choose L and C, which is determined by omega C cutoff frequency, image impedance at zero frequency. The above result are valued when the image filter is terminated by the image impedance. This is the major weakness of the design because the image impedance is a function of frequency, is not likely to given source or impedance. The disadvantages of this file is attenuation is rather near cutoff, remedies in derived session. When you see that constant K filter design suffers from the disadvantage of relatively low attenuation pass cutoff and non-constant image impedance. The M derived filter session is a modification of K session designed to overcome this problem. So the development of M derived session. So using this M derived session, we are having constant K section, M derived session and finally M derived session. You can see the arrangement which we will derived from the image impedance parameter. So if you consider the M derived filter section, We will have several network in terms of resistance, in terms of T and pi filter. This T and pi filter are most commonly used filter network for microwave system. If you considered our microwave transmission, we want to know the importance of this constant K session. So from this you will know about image impedance transformation method. Thank you.